So now we just discussed only the movement of electrons. Now we will be studying the rules of resonance. That what are the rules of resonance, and after understanding the rules of resonance, it will help us to understand the reactivity of molecule. And reactivity, believe me, the reactivity of molecule is very much important, and it plays a great role in understanding the organic chemistry, because majority of the reactions you will understand when you understand the behavior of a molecule, or the active part of the molecule, that how the molecule will react. So those things will help us to understand the chemical to understand the behavior of molecules. And the behavior of molecule is an important tool in understanding the chemical reactions. So we'll be studying now the rules of resonance. Okay, so we are still studying the resonance, and we are now studying the rules of resonance. These rules of resonance, they are very important. How they are important? That will that will help us to select that which structure is very important among the resonance forms, and that structure which is very important, that will lead us to the actual structure of the molecule and will tell us about the reactivity of the molecule. So there are some rules, and I want to discuss the most important rules which are very much important and which will help us to understand the actual structure or behavior of the molecule. So we should not go into to study many rules. Those rules which are very much important and which are very much basic, we need to study those. So this rule says that the resonance structure is good which has more covalent bonds. Okay, or you can see, let me draw the structure of this molecule. Suppose, let me use this ballpoint marker, the electron come here, and now the electrons sit here. Suppose the electrons move there. Now what happens? CH2 CH, I should write it like this, a double bond C H CH2. This is one structure, okay, but the electrons can move in the other way too. These electrons can move here and here, so this will be negative and this will be positive. Okay, so both are the same, but I should write it. Now this is another structure. The electron move here and the electron moves here. Okay, now let us move a little bit faster. Okay, so the electron move. Now this acquire positive and this acquire a negative charge. But as you see, this is a primary carbon, it requires a positive charge. This is a primary carbon, this requires a positive charge. So they are the same thing. This is a primary carbon which acquired a negative charge, and this is a primary carbon which also have a negative charge. So these structures are almost similar, or they are similar. In fact, I should have drawn this hydrogen, but there is another structure also, and you should see it. Suppose that these electrons comes and sit on this carbon. It is very much possible. And these electrons comes they're now not making a bond. They are not coming here. They just sit on this carbon, and they just come and sit on this carbon. So you have another resonance form structure produced. This is the CH2. This is CH. This is the double bond. Okay, and this is CH2. Oh, I'm sorry, I should write it a little bit clearly. This is wrong. CH2. This is positive. CH. Now this thing becomes negative. This is our single bond. This bond, I'm writing it like this. H. This acquire a positive charge, and this suddenly a negative charge appear on this. So the rule states, the first rule and very important rule states that there should be more covalent bonds in the molecules. So as you see, this molecule, it has many covalent bonds. 1, 2, 3, 4, 5. We should not count those with the CH, okay, the hydrogen, because all of them have those. So 1, 2, 3, 4, 5. It has 1 and a 2 and a 3. This has 1, 2, 3, 4. This has 1, 2, 3, 4. So this is good structure. This structure is not good, and we will see in later cases that why it's not good. And this structure is again not good. This is the best. These are okay because somehow they have some covalent bonds, 4, 4, and this is very worst structure. So this same rule tells us another thing also, that a resonance form with many charges is very bad, and a resonance charge with very less charges is very good, or is the best. As you see this molecule, okay, so this molecule doesn't have any charge on any carbon. This has 2 charges. Right now we are again not studying that which carbon is important, which structure among those structures which is important. Almost they are the same structures, okay, so it will be clear to you in the other examples. So it has just 2 charges, a positive and a negative, a positive and a negative, but this is a negative, a positive, and 4 charges. So this structure is worst. This is out. And another thing should be noted, in all resonance, those resonance forms are acceptable, okay, which have the same net charge. From net charge, this has a net 0 charge. As you see, this is a positive and a negative. Positive and negative means it is a neutral, okay. Neutral, from neutral mean 1 positive 1 negative is equal to 0. This is again neutral, 1 positive 1 negative is equal to 0. This has 2 negative and a 2 positive, this is equal to 0. So this is a resonance form, okay. But there is other thing, it has many positive charge, so it is worst. These are okay structures, not good, but anyhow not very bad, no, not the worst. These are, you can say, poor structures, okay. This is worst, this is a little bit bad structure, and this is the good structure, okay. So they will help us. These are the structures which we will be discussing, and they will help us to understand many things, okay. Look at this structure. This is an alkene, or in fact a diene. Diene means that it has 2 double bonds. Both the bonds are conjugated, okay. So these are all the resonance form of these molecules. You can say that they are all resonance forms. How this structure would be formed, or how can you form this structure? This can be formed like this. When these electrons come and sit on this carbon, this will acquire a negative and this will acquire a positive, this carbon. And when those electrons comes and sit on this carbon, this will acquire a positive and this will acquire a negative charge, okay. This is one structure. Now what about the other structure? This one. Suppose those electrons come and sit on this carbon. Again, this is a valid resonance structure. It will be produced, it will form a positive, a negative charge because both electrons sits on here. It will be a negative. What about this thing? Now, those electrons sit on this carbon, a negative charge appears, and the electron move from this bond. So this is a positive carbon. It will become a positive carbon. Now let's move to the other structures. Okay, what about this structure? It is from here it seems that electron has moved from this carbon. So suppose those electrons, they move from this carbon and sit on this. Here it will be a positive charge and it will be a negative. What about this? Here it is a negative and it will be a positive charge. Now what about this structure? Look at this structure. This is like the electrons have moved from this bond and sit on this carbon. I'm sorry. Okay. Sit on this carbon. But the electrons now here, they sit on this carbon. So this will be positive. This will be negative. As the electron came from this bond and sit on this carbon, this is negative. The negative, if you can't see it, it is a negative and a non-bonding electron, and this will be positive. This will become positive. Okay. So these are the other structures. Now my aim is I want to show you something else. I have written all those structures, but okay, let's focus on this structure. This is the CH3. I should write it a little bit cleanly. Now, how this structure might have formed? When this electron moves here, so a double bond is produced and those sit on this carbon. So what happens? Here a positive charge is produced, and here what happens? No charge appear on those carbons because as the electron comes and the electron move away from the same carbon, so a negative charge appears here. Okay, so this is another structure. What about this structure? If the those electrons moves here and those electrons move here, what will happen? It will acquire a negative charge and that carbon will acquire a positive charge. So the aim of showing all these structures is to make you understand that which structure you need to select, which is important structure. Those structures which are important will lead us to the actual structure of the molecule. There are rules that those structures which have many covalent bonds and less charges are most important. So as you see, this has no charge on any carbon, so this is the most important. So this has no charge, so it is very important. What about this? This has 2 charges and 1, 2, 3, 4 covalent bond. 1, 2, 3, 4. It has 4. This is okay, and this structure has 4 covalent bond. This seems a little bit okay too. Okay, then what? Okay, then those things. Look at this. It has 1, 2, 3, 4 charges. It has 1, 2, 3, 4 charges. So structures like those are bad, or you can say these are worst. So we should not select them, and we should not even waste our time on selecting that which one of those are good and which one of those are good. So they're all rubbish. Okay, now we need to come to those structure number 5 and structure number 6. Okay, we have left with this good one, extremely good one, and those fair one, not very good but so. Okay, this has 2 charges and this has 2 charges. Now we need to select between 5 and 6 that which one is good. Now our previous knowledge will count here. As you see that here there are 2 charges, a negative and a positive. Here again there are 2 charges, a positive and a negative. Now which among those structures is good? Okay, so okay, this structure has a negative charge on a primary carbon and a positive charge on a tertiary carbon, and as you know, and this structure has a positive charge on a primary carbon and a negative charge on a tertiary carbon. Now, as you know that the tertiary carbocations, they are more stable than primary carbocation, so this thing win. Now, and again you know that the negative charge when is present on a, when there is competition between a primary or a tertiary carbon which is having a negative charge, so that structure will be appreciated or will be good in which the negative charge is on the primary carbon. Okay, so if if you are mixed up or someone is confused, they should study the previous lectures. That's why those tools, the electronegativity and the inductive effect, were important, because that will make us understand the resonance phenomena in organic chemistry, and ultimately will lead us to the reactivity of the molecules. So this thing and this thing, now they are in competition and they are all rejected. Very positive charge, so no net worth. Okay, suppose, okay, so we will need to select this structure. This is the best one among those two. This is very best, and this is okay, and this is bad. This is good, this is bad, those are worst. Okay, so what the good mean, what the bad mean, and what the very good or excellent structure mean. So when we'll practice those things and some other rules, then we'll be studying that what good structure, if some structure is good, so what? If structure is second good, so what? Those good one, very good one, and those structure, they will lead us to the true structure. You will see that we have what is the true structure. So we can now understand one thing, that is that those are not the true structure of this thing is not like those. It is not like this and this, because this is not good, this is not bad but not very bad, this is what these are worst, and I don't have any other word. These are worst. This is bad, this is not very bad and not very good, so the actual structure lie between this and this, and we will discuss what is actual structure, but before that we need to finish the rule. When we complete the rule, then we will come that what the good structure means and what the bad structure means. That will help us and will lead us to the reactivity of the molecule, and we will understand what the actual structure is. So we will be studying the other rules.